Good morning. Today we're going to take a look at transformations of our functions. I'm looking at the graph, see what moves it up, down, left, right, see what stretches it, see what shrinks it, see what flips it, and all those good characteristics of a function. So we're going to be studying all kind of different functions this semester. Today we're going to take a look at a quadratic function and the different transformations that happen. And then I'm also going to take a look at the square root function, which is also called the radical function. So functions pass the vertical line test. So I can see right here, if I were to draw straight lines through this graph, it's going to pass the vertical line test. So it's not going to touch in more than one spot. So I've started with the basic parent function. So this is the basic quadratic parent function. I'm going to go through, and as you can see, I've added different numbers or subtracted it, whatever, from my parent function. And we're going to see what effect that has on our graph. So let's take a look at the first one and the second one. So notice from the red to the blue, I would expect you to tell me what transformation happened. So it's going to be very helpful if you use Desmos. That's going to be a great tool for you to use all semester. And the more of these you do, you'll be able to just look at the number and be like, oh, I know it does X, Y, and Z. So x squared to x squared plus 3, it goes up 3 spaces. I know that because I can just look at it and count. So this is 1 space where my arrow is. This is 2 spaces, and this is 3 spaces. So I know that it moves up 3. I can also tell that by looking right here at the plus 3. So that tells me it's going to go up 3. All right, let's see what happens from the first graph to graph number 3. So this time I'm looking from the red to the green. So the red one starts at the origin, and it now hits the y-axis down here at -5. So what happened? You would say it went down 5 spaces. So you would say the transformation, the function moved down 5 spaces. All right, let's try graph number 1 with graph number 4. This time I'm looking at the red and the purple. So the red one starts here at the origin, and notice it slid to the left. So it translated to the left. And more specifically, it translated to the left 1 space. So for number 4 here in the purple that I'm hovering around, you would say that it moved to the left 1 space. Now let's compare that with graph number 5, see what happens. Now I'm looking from the red to the black colored quadratic function here. So the red is always your starting point, so notice I'm keeping that in there for you to look at. So I started the origin and it moved over 1 spaces, 2 spaces, 3 spaces, 4. So it moved 4 spaces to the right. Now I do want to summarize this for you, even though we have some more to look at. If I had to if I have a number on the inside of any kind of grouping symbols, then it's going to move left or right. So the +1 is the opposite of what you think. It actually moves left 1 space. This -4 actually moved right 4 spaces. And by graphing it, you'll visually be able to see that. As opposed to these two graphs out here, the x squared plus 3 actually moved up 3, and the -5 moved down 5. So these two are actually what you think. But if it's inside any kind of parentheses, a square root, any kind of grouping symbols, it's going to be the opposite of what you think, and it's going to move it left or right. All right, let's see what else we can make happen to our quadratic. We're on graph number 6. And sorry that they're both red, but I'll try to talk my way through it. So this is the parent function. And then notice what happens when I activate graph number 6, the 3x squared. So it got skinnier. Notice it is a vertical stretch. It got skinnier. So let's go through that again. It was wide. This is my original graph. And in front of the original graph, let me type up here. In front of the original graph is the number 1. Notice I went from 1x squared to 3x squared. So notice it's a vertical stretch. Think of like a rubber band and you're pulling it and it gets skinnier. So that is a vertical stretch. Let's compare that to this 1/3. All right, let's see what happens when I activate the 1/3 x squared. Notice it got wider. So it got fatter, so to speak. So that is a vertical shrink. So the first one is a stretch, and the second one, I pulled it out, so it got wider. So if I activate both of these at the same time, the one here that my mouse is hovering over, that's the one that's a +3. So anything greater than 1, okay, anything greater than 1 is going to pull it in. It's going to be a vertical stretch. Anything between 0 and 1, so fractions, is going to pull it apart and it's going to be wider. And the last one I want to take a look at, let's see what happens if I add a negative in front. Boop, it flipped it over the x-axis. So here's my original quadratic function. Notice when I do f of x equals negative x squared, it flipped it over the x-axis. So it reflected over the x-axis. Now, these transformations happen for every single function. Again, these transformations happen for every single function. So even though this is a quadratic, notice I'm going to go through my square root function here, and the same rules are going to apply. So this is the square root of x. Notice what happens when I put a plus 5 on the outside. It moved it up 5. So I started at the origin. The blue one popped up. It moved the whole thing up 5 units. Same thing that we saw with the quadratic. Notice what happens when I activate number 3. I got the square root of x minus 3. That one is going to go down 3. So it moved down 3 from where we started at, and I can see that from my equation as well. Now, let's see what happens when I have the square root of x minus 2, and the x minus 2 was inside of the square root part of my function. It moved right 2 spaces. We started at the origin, and we moved right 2 spaces. So let's see what happens when I have the square root of x plus 4. That one moved left 4 spaces. So again, this is what I was saying about any kind of grouping symbols. If you have any kind of grouping symbols, it's the opposite of what you think. So this x minus 2 in the purple, it actually moved it right 2 spaces. This x plus 4 in the black color, it actually moved it to the left 4 spaces. So number 2 was up 5. Number 3 was down 3. Number 4 in the purple, it actually moved right 2 spaces. And number 5 in the black, it actually moved left 4 spaces. If you add a negative in the front, it reflects it over the x-axis. So again, this is my parent, not quadratic, this is my parent square root function. It reflects it over the x-axis. Boom. And notice if I add a negative on the inside, this time it's going to reflect over the y-axis. So on the outside is the x-axis, and on the inside is the y-axis. And last but not least, I can make it stretch and shrink like we saw before. If I put a 3 in the front here, notice it's going to be a vertical stretch. Notice it got kind of like taller, so to speak, so a vertical stretch. And if I type in 1, let's make it do, kind of get flat there. And I will come down here. Let me move this out of my way. This time I'm going to hit the square root and x. And notice the purple that popped up. So the 3 on the outside here was a vertical stretch. Think of a rubber band. We're pulling it. It got taller. And this purple was a vertical shrink. So these are all of my transformations. I can move it left, right, up, down, flip it, stretch it, all that good stuff. And it'll help me move my parent function to different places.